Hello students. In the previous videos we showed you how to use the Pythagorean theorem to find an unknown side length of a right angled triangle, and we also showed you how to determine if a particular triangle is right angled or not. So in the next couple of videos we're now going to show you how to apply this to some practical situations. Okay, look at this diagram on the right, please. Now the secret with solving problems like this, well, there's two secrets. One is you've got to read the problem very carefully so you understand what information you're given and exactly what it is you're trying to find. And the other secret is you need to take this picture and turn it into what I call a mathematical diagram. Now the mathematical diagram only has the information you need to solve the problem and nothing else. So I'll show you what I mean here. Okay, so the question is, what is the length of one of the diagonal supports of the frame shown? So there's the two diagonal supports. They're both the same length. Because the information is given here, I'm going to try to find the length of that diagonal support. Okay, so I read the question and I know what I'm trying to find, and the accuracy is to 2 decimal places. So what I need to do is redraw that diagram with only the information I need, which effectively is just that right angled triangle. Okay, it doesn't have to be particularly accurate. It has to be clearly drawn so you know what you're doing. You need to put all of the given information into the diagram. So because that's 85, that's 85. And for the side that you're trying to find, you've got to put a variable on that side. So in this case, I'm going to call it D to stand for diagonal. So that's really the new steps in solving applications, is to get from the words to the diagram. And again, only include the information that you need. Okay, now we can proceed as we've done previously. The hypotenuse is that length, so I'll call that C. That's the short side, so that's A. That's the other side, so that's B. Write down the Pythagorean theorem. C squared equals A squared plus B squared. In place of C, we replace that with the letter D. A is replaced with 74. Whoops, that's not a 7, that's a Z. A is replaced with a 74. B is replaced with an 85. Now we have to simplify the right-hand side. So I'm not real good at squaring 74 in my head. So what I'll do is I'll do the entire right-hand side in one step. 74 squared plus 85 squared. And that gives me 12,701. Now I've got to solve this for D, so I undo squaring by taking the square root of each side. And I've got to round it off to 2 decimal places. So square root of answer. And I get 112.698, so the 69 has to round up to a 70 because of that 8 in the 3rd decimal place. So 112.70. And that's in centimeters. By the way, it's a good idea to leave that 0 in your answer, just because you're showing that you've actually rounded off accurately to the nearest 100th of a centimeter and not just a 1/10 of a centimeter. Okay, for the rest of the applications, I'd like you to have a go first and then check your answer. So you'll stop the video, have a go, and then come back when you're finished. Okay, welcome back, students. Now the secret to these questions, as I said before, is to read carefully. So a ladder 3.5 meters long is leaning against a vertical wall with the base 1.5 meters from the bottom of the wall on horizontal ground. So I have a vertical wall horizontal ground, and a ladder. And by the way, always write in your right angle on your diagram. Okay, where do I put the numbers? Well, the ladder is 3.5 meters long, so that's the sloping side, 3.5 meters. The base of the ladder, which is there, is 1.5 meters from the bottom of the wall on the horizontal ground. So the 1.5 meters goes there. And the question is, how high up the wall does the ladder reach? So it's looking for that distance just there. So I'll call that h for height. Okay, so again, that's the tricky bit, is going from the words to the diagram. Now it's pretty much the same as we've done before. So that's the hypotenuse. That's the short side, I'm assuming. That's the other side. And as before, we start by writing the Pythagorean theorem. We substitute A is 1.5. B is replaced with the letter H. Now 3.5 squared. Let's do that on the calculator. Is 12.25. Now 1.5 squared I can do in my head. I know that that becomes 2.25. And now I have to solve that equation for h. So the first thing I do is I subtract 2.25 from each side. Whoops. They cross out, leaving just h squared, which I'll write on the left. 12.25 minus 2.25, that one I can do in my head. To undo squaring, we take the square root, and h equals the square root of 10. Now we need to round that to 2 decimal places. So let's go ahead and do that. Square root of 10. And I get 3.16. Because there's a 2 with the third decimal place, that doesn't change. So 3.16 meters rounded to the nearest tenth, rounded to 2 decimal places. So once again, reading carefully and getting the right diagram is the key to solving questions like this. Okay, have a go at this one, please. Okay, let's see how you went. So a rope is tied to a vertical tree trunk 2 meters from the ground. So you got to picture this tree standing up, and there's a rope tied to it 2 meters above the ground. So having a picture in your head is really important for solving questions like this. And the rope is attached to the ground at a point 1.2 meters from the base. And how long is the segment of rope between the tree and the ground? Now it doesn't actually say the ground is horizontal here, but you have to assume that it is, otherwise we're not going to get a right angle triangle. So we have a vertical tree, we have horizontal ground. On this tree, from that distance to there, we're told that the rope is 2 meters above the ground. There's a right angle. We're assuming the ground is horizontal, and that's attached 1.2 meters from the base of the tree. And the question is, how long is that segment of rope? So I'm going to use, I won't use an L for that. It looks too much like a 1, so I'll just use D for distance. And there's the diagram. And we didn't actually have to have that little segment on the top, but that's the whole tree, so I decided to leave it in. Okay, once again, we've done the hard bit now. We've gone from the words to the picture. Let's go ahead, label the 3 sides. That's C, that's A, that's B. Pythagorean theorem, c squared equals a squared plus b squared. In place of c, I'm going to write d for distance. In place of a is 1.2. in place of b is 2. Let's simplify or evaluate the right-hand side. 1.2 squared plus 2 squared. I always should be checking, by the way, to make sure what I've typed is what I should have typed. It looks pretty good. And that gives us 5.44. To get rid of the square, I take the square root. And once again, it doesn't tell us how much accuracy. So I would say if we're working to 1 decimal place here, we'll probably leave it to 1 decimal place. So the square root of 5.44, square root of answer, and to 1 decimal place is 2.3, and that stays the 3 because that's smaller than 5. So to 1 decimal place, 2.3 meters. Okay, so that's some examples of solving word problems. In the next video, we'll continue with this and look at some slightly harder problems.